Good morning, everyone. My name is Tifro, and I'm a Google Cloud Architect with Clear Services LLC. Welcome to the Google Cloud VMware Engine Storage Option presentation. First, we'll have a look at the storage options available. Then we'll have a look at a VMware vSAN data store. How do we scale these data stores, and how can we leverage external NFS data stores with VMware Engine? When it comes to the storage options available, there are two main categories: storage for workload VMs that run on VMware Engine, and storage for the VMware Engine infrastructure itself. Storage for VMs running on VMware Engine, what we mean by that is storage that is directly accessible from the VMs running on VMware Engine using in-guest tools. For example, using the iSCSI software initiator available in Windows and Linux to connect to an externally hosted block device, or from a Linux perspective, mounting an NFS export. From a Windows perspective, access an SMB share or leverage GSUtil to connect into Google Cloud Storage and interact with the storage objects. Some of the offerings that provide these external storage options for VMs are Google Cloud NetApp Volumes, Google Cloud File Store, Google Cloud Storage, NetApp Cloud Volumes on top, and potentially other offerings available through the Google Cloud Marketplace. Use cases can vary from VDI to file sharing between VMware Engine VMs or VMs running both on Compute Engine and VMware Engine, and maybe even extended into bare metal environment. While the concepts are broadly similar between VMware Engine and Compute Engine, there might be a slight difference when it comes to the network path between VMware Engine and those external storage options offered elsewhere in Google Cloud. But other than that, the concepts for both VMware Engine VMs and Compute Engine VMs are the same. For this module, we'll focus on storage options for the VMware Engine infrastructure itself, and then specifically the data store capacity. So, what is a data store? A data store is a storage area where all the files that make up your VMs are stored. Think of it as a place to keep virtual disk, multiple virtual disks per VM, log files, configuration files, and swap files. Essentially, all the files that make up a VM or multiple VMs are stored on a data store. VMware Engine uses vSAN technology, a software-defined enterprise storage solution. vSAN forms the basis for the hyper-converged infrastructure architecture from VMware that VMware Engine is built on. Therefore, there's always a vSAN data store available in VMware Engine. Customers may also choose to add additional capacity by using external NFS data stores. So, in addition to the always present vSAN data store, NFS data stores can be added to this environment. We'll look more closely at both options during this module. Let's start by understanding vSAN, what a VMware vSAN data store is. Typically, a vSAN cluster consists of multiple ESXi nodes. Each of these ESXi nodes or servers has internal disk or storage devices. For VMware, these are typically NVMe attached flash devices, referred to as disk, which are placed into disk groups. Each ESXi node contains one or more disk groups. All the nodes in the cluster contribute capacity to the vSAN data store through these disk groups. Essentially, all the disk groups from all the nodes in a cluster are combined into a single vSAN data store spanning the entire cluster. To ensure balanced configuration, all nodes in a cluster must be of the same hardware type. For example, a cluster that consists of both VE1 and VE2 node is not supported in a VMware Engine private cloud. When it comes to data protection, vSAN doesn't rely on hardware read within each individual ESXi node. Instead, it uses intelligent data placement policies to store and protect data across nodes in the cluster. There are also storage efficiency, sorry, Technology like team provisioning, deduplication, and compression that help reduce the amount of capacity needed to store your VMs. Let's discuss vSAN storage policies, specifically data protection. vSAN uses a concept called failures to tolerate, or FTT. FTT defines how many device or complete host failure a virtual machine can tolerate. It's a storage-based policy that applies to all the files that make up a VM. Because FTT provides protection, it affects how much storage each VM will need. In order to protect the VMs, vSAN support both mirroring and erasure coding to store more data across nodes in the cluster. Mirroring typically provides higher performance, while erasure coding offers enterprise-grade performance but with a lower storage requirement. For example, storing a 100 gigabyte virtual disk with FTT 0, which we don't support for production, takes 100 gigabyte of space with just one copy of the data. With FTT1 mirroring, we require 200 gigabyte of space, essentially storing two copies of the data. We can also achieve FTT1 using erasure coding. However, this will increase CPU and memory resource costs, but means significantly less storage is needed. Here, you can see various levels of FTT using mirroring or erasure coding, each with different storage requirements. Some database servers may require mirroring, but for most VMware Engine workloads, FTT with erasure coding is suitable as we use local or flash storage devices in each node. So, does data protection using RAID 1 or erasure coding affect the number of nodes? What you see here at the top of the screen is FTT1 using RAID 1. When we write 100 gigabyte to the vSAN data store, there are two full copies of the data, and there is an additional node required to store a witness component. The witness component has metadata about the data written to the vSAN data store, and it plays a function in failure scenarios when reading and writing to one of the two copies. The witness component is stored on the third node. It's not shown here in the diagram, but it's required to make FTT1 RAID 1 function. At the bottom, you see 100 gigabyte again written to the vSAN data store. It writes three copies of the data if we use FTT2 RAID 1, but every mirror has its own witness component. Therefore, there are two additional nodes required to store the witness components to contain the metadata about the data that's written to disk, and also to make the decisions in failure scenarios when reading and writing to the vSAN data store. So therefore, 5 nodes are required for FTT2 RAID 1, and 3 nodes are required for FTT1 RAID 1. A lot of FTT. Now, with erasure coding, this is slightly different. With erasure coding, RAID 5 FTT1 at the top of the screen, you can see we write 100 gigabyte to the vSAN data store. It's actually not a full copy, but it is spread across 3 nodes at minimum. And then there is also a parity calculation, which requires a minimum 4th node. So for erasure coding FTT1, it requires 4 nodes minimum, which is 1.33 times the capacity. Where on node to fail, we can still reconstruct the data when reading from the vSAN data store. Similarly, at the bottom, you will have RAID 6, which is essentially the same as RAID 5, but now with double parity. So instead of the ability to lose 1 node, we actually have the ability to lose 2 nodes. And we are still able to reconstruct the data, and therefore this requires a minimum of 6 nodes. So the data plus the 2 parity in terms of capacity, it requires 1.5 times the disk capacity. How do we scale a vSAN data store in VMware Engine? We have two main options available. VMware Engine full nodes. These are our regular nodes that provide linear scaling of all resource, CPU, memory, and storage. And then we have VMware Engine storage only nodes. This only scales storage capacity. It's important to understand that storage only nodes cannot host any VMs. They can only be used to add additional storage capacity to a vSAN data store. Storage only nodes are currently only available for VE1 node types. They come at a lower list price, which might vary based on factors like VE1 or in the future VE2 nodes, and the overall VMware Engine software SKU being used. Currently, the maximum discount for storage only nodes is 25%, but it could be lower depending on the VMware Engine software SKU. Contact your local rep sales specialist for the latest pricing information. To scale a vSAN data store with hyper-converged infrastructure nodes, you simply add additional nodes into the cluster. As new nodes are added into the cluster, the vSAN data store expands to include the new nodes. Storage is available to all nodes and therefore all VMs across the cluster. This offers linear scaling of all resources, CPU, memory, and storage, as all nodes within a VMware Engine private cloud must be the same hardware type and contain an identical amount of CPU, memory, and storage. However, if we don't need the extra compute but need more storage, say for disaster recovery with SRM or for storage heavy VMs, we can add storage only nodes. Again, the data store spend all nodes and VM on hyper-converged infrastructure node can access the capacity added by the storage only nodes as well. This allows for independent scaling of storage resources compared to CPU and memory, potentially offering cost optimization or the ability to have storage heavy VMs without over provisioning CPU and memory. Let's recap some key points. Capacity expansion is customer managed. vSAN is always part of VMware Engine. When you add storage only nodes to the cluster, it's a continuous capacity expansion of the existing vSAN data store. There's not a separate additional data store created. Storage only nodes provide similar high performance nodes as they use the same networking technology in terms of bandwidth and connectivity into the switch infrastructure and use the same NVMe flash storage. Data protection policies and storage efficiency technology are consistent across the data store regardless of node type. Importantly, a cluster with storage only nodes can only have up to 50% storage only nodes. So an 8 node cluster could have a maximum of 4 storage only nodes. A 7 node cluster could only have 3. The smallest supported cluster configuration is a 3 node cluster with 2 full nodes and 1 storage only node. Customer may also need to consider adding external NFS data stores. This might be suitable for storage heavy applications that don't need the high performance of vSAN or to supplement vSAN capacity during disaster recovery scenarios where the VMware Engine cluster is undersized for storage capacity compared to CPU and memory. This can be achieved with products from partners such as Veeam, Zerto, or Rubrik. However, it's not currently supported using VMware Site Recovery Manager SRM because the SRM licensing model requires a vSAN only target. This may change in the future, but for now, this is the restriction. These are the supported solutions for hosted NFS volumes that can be mounted as data store in VMware Engine: Google Cloud File Store and Google Cloud NetApp Volumes. Both have gone through the certification process and are supported. Both are Google Cloud first-party services integrated into the console. Google Cloud File Store offers 3 service tiers: basic, regional, and zonal. Only zonal and regional tiers are supported with VMware Engine for the data store use case. They provide different performance levels and availability, zonal being faster with a single zone and regional spanning multiple zones for redundancy. Google Cloud NetApp Volumes offer various performance tiers: Flex, Standard, Premium, and Extreme. You can even move volumes between the Premium and Extreme tiers allowing you to optimize performance and cost while data remains in place. All solutions come with backup, snapshotting, and replication options. Currently, there's no customer usable interface to configure NFS data stores yet. Customer can request an allow listing, and once approved, Google Cloud Support will work with them to ensure proper network configuration and mounting of the data stores to the VMware Engine nodes. The target availability for this user interface is currently the first half of 2025. Here's a high level overview. There are two services: VMware Engine with its embedded vSAN data store and Google Cloud File Store, or Google Cloud NetApp volumes, which can host NFS volumes for use as data stores. Disconnect using VPC peering, so network latency and bandwidth between VMware Engine and the file service need consideration. It's important to note that this is not a continuous space. The vSAN data store appears as one data store, and the NFS volumes appear as separate data stores in the vSphere client. There's potentially a lower performance level associated with the external NFS data stores due to latency or bandwidth limitations. In summary, the certified NFS options offer snapshot, replication, and backup solution. They come in multiple performance tiers with corresponding price points, with some allowing on the fly adjustment. Currently, allow listing is required, and Google support will assist with configuring networking and mounting the data store to VMware Engine. Finally, it's worth noting that, like VMware Engine, both file store and NetApp volumes are Google first party services, allowing for more streamlined support. Thank you for listening to me. Until the next presentation by Clear Services LLC, I'll see you then. Really, thank you for watching. I really appreciate your time. Bye.